Hi, all. Here we are again. We're going to talk about Ohm's Law and power. Ohm's Law is a relationship between the voltage, the current, and the resistance. As I mentioned in a previous podcast, the I stands for current because our good friend Ohm was measuring the intensity of the current. Here's Voltaire, which we name volts after. Here's ampere, which we measure current after, and of course ohm, or Simon Ohm, we measure resistance after. We have this relationship. It can be rewritten as V equals I times R, or I equals V over R, or R equals V over I. And you can see the current is directly related to the voltage, and that should make sense. If you increase the pressure, you're going to get more flow. It's inversely related to the current, or to the resistance. So if we increase the amount of resistance, we're going to reduce our flow. So let's put it together. V equals I times R, R equals V over I, and I equals V over R. We can simply solve for various things. If the current is 2 and the voltage is 6, what's the resistance? Looks like we're going to use this one. The voltage is 6, current is 2. Looks like we get 3. What was the voltage? If we know the current is 5 and the resistance is 6, looks like 30. And what is the current? If we know the voltage is 3 and the resistance is 6, looks like a half an amp. By the way, we use the Greek letter omega to represent ohms. It wouldn't do a very good job for us to write 30O for ohms, because now that 30 for ohms, because it looks like 30. So we instead use the Greek letter omega to represent ohms. What about power? Well, power is the rate at which the current, the energy is used in the circuit. We measured it in watts. You're probably familiar with a 60-watt light bulb. That's the rate at which the energy is used. So power is the current times voltage. How did we know that? Because again, it's the rate, there's time, at which energy is used. So energy per time is a watt. How do we get that? Well, when you have charge per time, which is current, and voltage, which is the energy per charge, charges cancel, and we're left with energy per time. So our new formula, power equals current times voltage. So let's suppose Rudolph, the red-nosed reindeer, has a 500-watt nose supplied by a 20-volt source. How much current does his nose draw? Well, power equals voltage times current, and therefore current is power divided by the voltage. The power is 500 watts divided by the voltage, which is 20, and that's left with 50 divided by 2, or 25 amps. Lastly, we need to talk about how the electric company charges you for electricity. They charge you in kilowatt hours, which is a really weird type of unit, but that's okay. So here's what they charge you at. They charge you 5 cents for every 1 kilowatt hour. The secret to doing this is kilowatt hours. Find the number of kilowatts and multiply that by the number of hours. If we read through the question, it says, what's the cost of running the TV for 2 days? Well, how many hours is 2 days? Right, 48 hours. In kilowatts, well, we know how to find the power. It's current times voltage, which gives us watts. So we'll have to convert that to kilowatts. And let's figure this out, what we have. The current is 8 amps. There it is. Use it 8 amps when connected to a 110 volt line. There's 110 volts. That would be 880 watts, which is the same as saying 0.88 kilowatts. So look at that. If you apply 0.88 times 48, you're going to get, I believe, 42.24 kilowatt times hours. And if they charge 5 cents for every one of those kilowatt hours, and we have a little over 42 of them, we have to multiply that number by 5. So it's 211.2 cents, or in other words, $2.11 and 2 tenths.